Hi, this is Bill Kearns from Blue Kernel IT. This video is about a project I wrote that takes XML that I query from the database and turns it into C# class files. During the conversion, there's some type analytics run that really show the permutations of all the different types based on the XML. Though it's a little unorthodox, I think there could be some practical applications for the project, which I'll talk about later. But the whole point of it is that I was experimenting with SQL Server data type link, and I wanted to demo some link functionality and using the iCollection and some C# code. So let's first take a look at the SQL file that I used to create the database. This is the file. I create a database and create a table BK data. First I import the schema that I'm using. I wrote this schema and called it the BK Blue Kernel extensible schema. It's extensible because this element here uses a process lacks any type. So any element and structure can be nested within this element as element content, or any subset of child elements, descendants, etc. So I was using this because throughout my experimentation, different websites and things, I've been playing around with converting XML to XHTML or just to HTML, always using a different schema. Here's one I have, the chat element, here's another one, the calendar schema. So if you notice in SQL Server, I go ahead and import this schema, and then into this table that uses the schema that I've imported here, BK extensible table. That is the XML data type within SQL Server. So this table has a primary key, an XML column, and a timestamp. Here's a function I wrote to create a timestamp, and then I do some inserts to insert the data. Now, because it's a lacks any content, it's basically used as a wrapper. The BK extensible schema becomes a wrapper for any typed XML or untyped XML that you wanted to insert as child rows. So I'm going to scroll down here. I was inserting some different records. For this demo, I'll be working with these two records. This record here and this record here. Now I'll explain a little bit more of this later. But to model XML, what you really need to know is the root element that the XML comes from, and then how many types deep is it. So I've coined some terms here. Throughout the application I'll use the database primary key, and then what I call the virtual root, and then the type ID number. So if you notice, this entry here actually has two entries. This is one entry, which is BK entry item. This is from the extensible schema, and then this is the actual entry data that we'll be working with in the ORM. And I'm sorry, this is the actual entry data we'll be working with in the ORM. So if you notice after some reformatting, there's a first nest type. This would be the base class. This class would be created in the ORM as first nest type, class first nest type. It would have a property, C, which would be a simple property, and then it would have a complex property, inner first nest type. Inner first nest type would actually become a second class. So this second class would be class inner first nest type, and it would have property C again, and another complex property, inner first nest type, which would be this class. So this section of the XML would actually become class inner first nest type, and would have one property, C again. As this relates to those three numbers I mentioned earlier, this would be virtual root 0. This would be type number 2. This would be type number 3. And this would be type number 4. When I model the XML in a recursive method, which I'll look at later, I always start with the innermost type, the innermost child type. So the rest of this record, second type, second nest type, this would be virtual root 1, so virtual root 0, virtual root 1, and this would have a property C, and then again, class inner second nest type would be a separate class that would have a property C again. So this record really contains some of the logic that I had to write as far as being able to nest types, have complex properties, and then their associated classes, and have that all generated as .c# files. This second record proposed the question, well, what if you have a sequence? So here we have one virtual root, and at the virtual root level we have a repetition of the same element. So you can't have 4 classes that are named A-type. So in this case, I made a condensed type, and I added some attributes that show which version of the type has which properties, which I'll look into later. After I run my script, you see I have my database table here in database type descriptor. It's called BK data. I'm going to select the top 1,000 rows. The first record would be the first nest type and inner first nest type, etc. And the second record would be the A type. So let's put some of those thoughts on the back burner while I explain the project setup. Here's my solution file for TypeDescriptor. I have 2 projects. There's BK generated types library. This is a DLL project where all of my generated types will be added to BK generated types. And I have blue kernel type reflector. This type reflector has several folders here. It's a console app. So there's the main program. There's a folder here, prototype collection, and there's a folder here, prototype actions. First I'll explain the layout and the hierarchy of the program itself, which methods call what. So we start in the program, the console app. There's 2 arguments that you can supply, either a 1 or a 2. Argument 1 means that the program would run through the XML generated from the database query and actually write the C# files to BK generated types. And if you supply argument 2, it's going to query the data and then use those generated types from step 1 and actually new up the objects into an object array in instantiate objects. So there's 4 objects I have, 4 classes: prototype source, prototype producer, prototype constructor, and prototype writer. These 4 classes handle generating and instantiating everything. So these 4 objects are called from the program file, maybe in a different order depending on which argument was supplied. The first class would be prototype source. Here we have create source list. So this method runs the query, and I'm just doing a select star from BK data for testing purposes as I implement functionality. And the second method is a recursive method, build prototype list. So this actually steps through each record of XML that's passed in as a tuple of X element and along the primary key, and some other info I use recursively to build some of the metadata associated with the objects that I use in memory in the middle. After the methods of prototype source run, I use the methods from prototype constructor. There's 2 here that are really important: build complex properties and build version attributes. So build complex properties enumerates this collection, which I'll explain in a moment, calls some of the static extension methods, and adds the property, the simple properties or the complex properties based on the class types from the recursion a step before. Build version attributes is the part that adds a declaration to the class type itself and every property, simple and complex, so that you have some permutation statistical data, which I'll explain after we see the final product. And stamp with utility methods uses the static type reflector to add some utility methods to the actual C# classes. This would be one that works with some extended functionality that I haven't finished totally writing yet. Once the collection has been modified, if you notice, I'm passing the same collection type through each of these objects by reference. I call the methods from prototype writer. There's two overloads here. I'm using currently the ones that work with each collection. So write each type actually writes the types that are then formatted correctly in the correct order in the property model collection to the output directory, adds the using directives at your discretion, and then optionally writes to the current code DOM. Since I structured the program to run in two steps, I'm not currently using write to the current code domain. I thought it was a more cleaner and more orthodox paradigm to write the class files completely in one step, then import them to the DLL, build the DLL, then actually use them to instantiate objects. So these method implementations in Prototype Writer are pretty simple. They just work with the metadata associated with the collection. And here's the code DOM method. Adds reference assemblies generated in memory and produces the results. So then I enumerate any errors that I have from the compiler. The last class I use is the prototype producer. So after the source query is run, the objects are constructed, the class files are written. I have prototype producer. It has one method, instantiate objects, uses a bit of reflection in the activator and a string based on the type name returned from the data set that the query ran to instantiate the object. Currently, I'm only instantiating objects that have simple properties. As of the last refactor of this code, I had gotten to the point where complex types are generated correctly as class files and written to BK generated types. However, I only support the instantiation of an object with simple properties, and this method is where I left off on this project. So now that I've explained the program flow, let's go ahead from prototype actions. Let's go ahead and look at the prototype collection. So there's 5 objects here. There's a prototype. The prototype is an object that's held by the prototype model. So you have a prototype model object that has a member property of a prototype. So from there, a prototype has a member property that is the prototype internal key. And from there, the prototype internal key has a member type that is the prototype extensible object. And this is the lowest level object here in the hierarchy. So from these 4 classes, the prototype model is just a wrapper type to be used by the collection, which I'll look into in a moment. I have a member-wise clone on all 4 of these objects, so they use a bit of reflection and pass the object down. From prototype model, you go to prototype. If you notice, out of these 4 objects, this is the only class that makes use of any properties. This is because the way I have an object query set up, all of the queries that belong to an object that use reflection function on the properties of this object, which I'll explain in a minute. But the important point is that this class makes use of the properties that I want to do dynamic link queries on, and each property has a static string representation for shorthand and code to know which property you're querying on, and then the property itself. So each of these properties has a static string you can use and the property itself. And from there, you'd go to the prototype internal key. Though I'm not using ACID transactions, as far as modeling the data, I wanted every prototype object to have a prototype internal key. So I have the record PK, the virtual root, and the type number. It also isolates a place for all the key information that you want to put into an object, which is good for down the road, for separation of principles. So then there's just some getters and setters, a clone, and a member-wise clone. And I implemented a compare, which I'll show the implementation of, or here's the implementation, the usage of, later. And last, the extensible object. This has the actual object value, the text value, along with any other metadata. For instance, I store the XPath expression from the original XML where it was in the record set as XML as an XPath expression. And some other things. Most of this, other than memberwise clone and the simple properties, I haven't made much use of yet. But there's some plans. So now let's take a look at the collection. I chose to use iCollection. This is because the order of the collection is important in respect to the primary key, the virtual root, and the type number. And I'm using an iCollection with a generic type of the prototype model. So throughout the code, well, let me explain this class. I overloaded the this reference a few times. So there's the this primary key. I have a toList to get the internal collection, which is really just a list. And I have a this with the primary key virtual root, which would return a new collection based on those two key arguments for each object that are stored in the internal key. And I have the this with the primary key virtual root type number. So there's some other methods. I overloaded toString to get the construction string. And then the iCollection prototype item. You can add a list of prototype items. An insert. This is for inserting in a specific spot. In addition to those three items, primary key, virtual root, and type number, there's also what I use is called a generation number. So the generation number is actually what's important in actually printing the class files in the correct order, which I'll show the usage of later. And a remove, replace, get enumerator. I'm not using all of those. So one thing I wrote that I developed this paradigm is an object query. When I say object query, I don't mean an object in the ORM, but rather an object in the collection. So going back to the prototype, we have all these properties that you can use, the property name, etc. And then in the bottom of prototype, I have some static extensions. I made some use of reflection where you can compare it by the key. This key would be the primary key, the type number, and the virtual root. Compare by properties, and compare by properties, and get value. So in the collection, I have some static extension methods. One that I'll explain, get property values. I'm returning an IRA enumerable of some type, get property values. So, and it extends the prototype model collection. I have a prototype query params and then a string property name. So what this method does, which I'll find some references, is you pass in the type you want to return that is the type that returns from the property, and a query params object. This object you would new up before calling the extension method. You new it up, and the only properties you assign are the properties that are queried on for each object in the collection. As you can see, you call this extension method on the collection, and then down the road within this implementation, each object, the prototype, uses compare by properties too, which was an extension method on the prototype. It was a quick way to extend querying to items in a collection. So I'll take a look at the implementation of this. So here on prototype model collection, there's get property values. I'm using this a lot of places throughout the code. Let's take a look at this one. Here I'm in build complex properties. I go through my collection. This is after the source ran and built what it could into each prototype object. I want to find out, well, how many record PKs are in my known types. So I send in a return type of long and a query param of null, and then prototype.db primary key symbol. This means that the list of primary keys doesn't have to start with 0. It could skip them, and because it's in a for each loop, it's really handy to return just the exact list of what's in the collection. So from there, for each record primary key that's returned, I start a new query params object. This is the gen number. I'm using a paradigm where if you pass in a -1, it means that it's the prototype model is not connected to the collection. So then I set the primary key of this query params, and then use this query params in the next for each loop, where I call the same collection and do get property values, but this time I'm looking for the virtual number. And I go through the same paradigm, query params, primary key, virtual root number from the virtual root from the record PK. And here I use this query params to get the type number symbol. So what these three loops do is record PK, virtual root, type number. So essentially all members of the collection that would relate to something like this or this or this are returned. So let's go ahead and start up the program. Right click on my project and make sure I'm passing in the correct command argument. First I want to write my C# files. I'm going to save this. And here, which would have opened on the screen, the program ran. Some metadata, some debug data I've been using. You can see that the gen number is added. This is sequential adding on the insert, the importance of using a collection so that for each type you can add a namespace, using directives, etc. At the right gen number so you get the object you want to extend. Make a new prototype model, assign the construction string, which would be some C# code, and then pass it in at the gen number that you'd want to insert at. So, and then you can choose on the insert method of the prototype model to insert before or after. That's the extension. Here it is. Yeah, so you'd insert before or after by the gen number. So I'm trying to give you an idea of the quick overview of how all this comes together. Some more debug and reprints the values. Here I have on the item print, I have to make sure that all these combinations are unique. And at this point, as it printed them out, this is right before it printed the class files. These gen numbers are correct. I'm not actually showing the gen numbers. This is the code that it printed out into the C# files. And we'll scroll all the way down, press enter to terminate. Let's go ahead and do that. And now our generated types should be here. And here they are. Here's a type, first nested type, inner first nested type, inner second nested type, and second nested type. So in this project, after I have written out the types, I'm going to explain a couple of the classes. I have a version type descriptor and a version property descriptor. Now if you notice, these elements were only used one time. There's only one instance of what would be a complex type in each one of these records. However, in this record, we have several instances of a type. So in a type, you actually notice the class had 4 different versions. And here's a list of all of the properties found in all of the classes. And then each property, this is the private, has a version descriptor, version property descriptor. So let me format this so it's a little bit more readable. What this actually means is that property A was found in versions 1, 2, and 4 of all of our 4 known A-type objects. This dips into some of the possible practical applications for the application later on. But that's that. So, and then there's the other ones. Inner first nest type has child inner first nest type, and so on. They all print out fine. Let's go ahead and run, since I don't have the complex type implemented, I'm going to go ahead and run the program with just A type. I'm going to delete that record and make sure that took select 1,000 rows. We're left with just A type. And I'm going to go back to the program, change my debug argument to 2. And I'm just going to hover over the objects that are created. So now that I have 2 as the program argument, I fire up the program. The same stuff ran up to a certain point, though it didn't rewrite these types. I skipped that step. And make this a little smaller. I'm going to step into this method. And here's my instantiate objects. Jump ahead to here. So what this is doing, it's going through all those queries again, and it's going to step through what the using directives are, which have no value, and the type itself, which has no value in this version. And so now we're instantiating a type, instance of object. It's A type, and it has these properties. So in here we're going to write out what the reflection generated. There we go. So it'll go through each property using the BK extensible object to get the actual value that was from the XML, look for the property name in the object, and write it out. So that's about where I'm at with functionality. As far as the practical applications, data mining, I've seen, definitely one time I worked at a company where they had a very large, disjointed, very not normalized data schema where some of their SQL, which you can query any SQL just using standard joins, left joins, right joins, etc., and just automatically turn it into XML. So using that practical application, I've seen companies where they had several entries that were comma delimited or semicolon delimited in one record that actually needed to be pivoted out. Maybe if there's an application that you can't use SQL Server integration services for, or if you had a web service and you were in a large organization and you had a database table, way over here with a whole bunch of joins that goes to this table way over here, and you wanted to quickly create a composite type. I would call this a composite type, or any of these a composite type, because using the for XML auto keyword in your SQL, you can query anything as XML data. So any kind of analytics, or if you had a very large data set and with a whole bunch of tables, and you couldn't track, at one time, these 3 columns in table A were null, and at a later time only 2 of those columns were null, but there was some business meaning as to where the nulls were. But you had that same situation repeat over many tables. Using something like this algorithm, you could normalize your objects because once you instantiate the object, you can use the type descriptor to get, let's take a look at this attribute class, which they're both here. The property version is here. It just returns the int array that it was written with. So you could see for that object, which version it came from, as they're newed up in memory, or see how many versions there are. Beyond that, it was a great project to study some LINQ, static extension methods, make a good implementation of a collection. I did use this great program called LinkPad, which I'm going to open up here. So LinkPad is this great program that if you're not very good at LINQ syntax, it really helps you learn LINQ syntax, etc. I get tongue-tied and can't type on the fly. And I also read these two books where I heard about this great program, F# tutorial and C# in a nutshell. So a lot of these deal with the simple things that LINQ does that are really pretty complex, and the extension methods for multi-threading, the new action methods, and then they went ahead and wrote a library of their own. So all sorts of fun things. I'm responsible for the ORM. Turning XML into type C# classes is definitely different. It's unorthodox. I don't know, but it was a challenge. So thanks for your time. This is Bill Kearns from Blue Kernel IT. Take care.